We're going to go over the problems that were universally missed of the people who took the test today. And we'll also try to cover a couple of things that are related to the problems that we're going over that I think will be helpful. Okay, so let us start. We're going to start. Oh, and by the way, Jackson, I am going to send out the solutions. As soon as people take the test, I'm going to send out individually to them the solutions and their results. So they can see which ones they missed and then look at the actual solution. So if anyone hasn't taken the test, that's why you haven't gotten solutions, but I'll send this, I'll send individually as you finish the test, I'll send you your results and the solution. Okay, so let's start with problem 7 from the sprint round. Okay, so I'm going to describe to you what that problem was. Let's see, 3 times 2. Radius. Okay, let me go back here. Look at the problem again. Oh, 2 by 3. Okay, so we are going to share screen. And we're going to do the whiteboard. Okay, so here is what the problem that everyone who took the test missed. Oh, and Jackson, have you taken the test? Are you there, Jackson? You look frozen. Can anyone see me? Ethan, can you see me? Or am I frozen? Am I frozen?
Yeah, I can see you.
Okay, okay, cool.
Sorry.
So,
I didn't find me, or am I frozen by
Jackson, I was just telling some other people who didn't take the test, if you'd rather, you can, and if you haven't taken the test and you'd rather, you can drop out, take the test, and then come back and watch the video, or I can give you the solutions, whichever you like to do. Okay.
Okay. Sorry, I was just frozen. I couldn't get through.
Yeah.
I followed the instructions, and then it took me to this page that said, like, you need to register first. And I guess I just haven't done that yet.
Okay.
How do I register?
Okay. So let's, what we'll do is just kind of go over that really quick. So, so I've sent you this link. If I'll send it out again, I'll send it out to everybody, but you go there. I'll just send you the instructions again. Did you follow the instructions carefully, or what?
Yeah, I followed them, but I just come up to this page that said, like, I'm ineligible, I guess, since I haven't registered.
Why don't we do this then? Rather than keeping Ethan waiting, let's let me how's the best way to get a hold of you after we're done today? Should I mean, you know, you can either stay here and watch, or I can, I have your dad's phone number. You can give me your phone number, or a good number to get you at, and we'll walk through it together. We'll share screens and walk through it together.
All right, I can stay here after.
Okay, cool. All right.
Thank you.
So, yeah, no problem. Okay, so here is the problem that we're going to talk about. And I know already, I think I looked at Ethan's test and I know where he might have messed up. Okay, so here's the problem. There's a window. It's called a Norman window. You don't need to know that, but that they give you that information. And basically it looks like this. It's a rectangle with sides 2 on the base and 3 on the height. And then the top is a semicircle. So I don't know the best way to show that. Maybe we'll go like that, indicating that that's a radius. Okay. Now, they want to know what is the area of this window. And immediately I knew where some people were going to mess up, and I think it's where Ethan messed up. So you guys are both in geometry, I think, right? So this is a pretty straightforward problem. So how are we going to calculate the area of this?
First, you're gonna do the rectangle 2 by 3 to get 6.
Okay, so this area has an area of 6. Now we got to deal with this, right? What's the formula for the area of a circle?
Pi r squared, and then since it's a semicircle, you divide it by 2.
Who said that last part about divide by 2?
I did.
Okay, so Ethan, I think here is where you might have messed up. And as soon as I saw this problem, I said, I bet you there's going to be some people who forget to divide by 2. So the area of a circle is pi r2. But you only have half of a circle here. So I think that some of the people who missed this had pi r2 and then forgot to divide by 2 because it's half of a circle. So what is the radius here?
1.
Perfect. So we got pi times r, which is 1. Let me just erase this. So you have pi times 1, so we'll just leave that off, and 1 squared is 1, divided by 2. So what is this approximately?
1.55.
Yeah, so it's more than 1.55. I mean, it's more than 1.5 is what I'm trying to say. So pi is about 3, but it's a little bit more than 3. And so pi divided by 2 is about 1.5, but the important thing is that it's more than 1.5. So we're going to say it's greater than 1.5. And the reason why that's important is that the problem says for you to round up to the nearest integer. So, this is another place where you could mess up. The first place is you could forget to divide this by 2. But the second place is you could forget, what are they asking for? They're asking for you to round up your answer to the nearest integer. So 6 plus 1/2 is equal to 7.5, but it's actually greater than 7.5. So when you round, I'm sorry, it didn't say round up to the nearest integer. It said round to the nearest integer, which is why I'm making a point of the fact that this is not 3, it's greater than 3, which means that this is not 1.5, it's greater than 1.5, which means greater than 7.5. So the next rounding to the nearest integer would make the answer be 8. So that was a pretty simple problem, as long as you know the area of a circle, and as long as you follow the directions and express the answer the way you want, and don't do a stupid mistake like forgetting to divide by 2. Okay? So let's go to, and I know you guys don't have any questions on that. So let's see, I'll erase all. Okay, here we go. Okay, let's go to the next one. Okay, so the next problem is problem 9. Okay, so this one is, it says there's a standard 6-sided dice and you roll the dice twice. So roll twice. What is the probability that the second roll will not be less than the first roll? Okay, so second is not less, I'm sorry, than the first. Or another way of saying that is that the second roll is equal to or greater than the first roll. Okay, so have you guys done much in probability? I think you guys are both in the same math level. Not much.
I haven't done any probability in school, but I've got like that basic idea.
Awesome.
Just
Okay.
watch videos.
There's 2 things that you need to remember about probability. One is that if you have 2 independent events, so I'm going to say 2 independent events, you multiply their individual probabilities. Oh, I'm sorry, and 2 independent events, and you want to make sure, and you want to find out what's the probability. Are you looking for scratch paper? I always have scratch paper. You're trying to look at the probability that they both happen, then you have to multiply the probability. So let me give you an example of that. So suppose that I have 2 dice and I roll the first one and then I roll the second one. And I want to know what's the probability that the second one is exactly equal to the first one. So I roll the first dice, and it doesn't matter what the results of the first dice is. It can be 1, 2, 3, 4, 5, 6. I can still match that on my second dice. So we can just So the probability of the condition that we're looking for being met with the first roll dice roll is 100%, or as we express it in probability, we just call that a 1. Okay. What is the probability of my second dice matching my first? What is that probability? Again, it doesn't matter what the first roll was. It could be a 1. What's the probability, if the first roll is 1, what's my probability that my second roll is 1?
It's another 1 in 6 chance.
It's a 1 in 6 chance. So my probability of rolling 2 dice and having them both come out to be the same is 1 times 1.
I'm the host now. Yeah. Can do whatever I want.
So he was glitching out and not me.
Yeah.
We missed you. You're on mute.
Sorry about that. So my internet died for like 20 seconds, but anyways, thanks for being patient. Okay, so let me come back to find my whiteboard, which seems to have disappeared. So okay, so here we are. So let me actually write this a different way. So if I have 2 independent events, so I'm going to say 2 events, and I want to know the probability of both of them happening, then we multiply their individual probabilities. So maybe you guys have come across logic and maybe you haven't. And by logic, I'm not saying like logic the way you think is logical. I'm talking about like computer logic. Okay, so in computer logic, there's some symbols that we use. And one of them is and we write it with capital letters. So what this means is that both things have to happen. Oh, you lost internet too?
No, I can't get on.
Oh, okay. Well, let me just see real quick because our internet died for a minute or so.
Oh.
So it looks like you're back on. Yeah. So try it now because we just lost internet for a minute. Okay. So whenever you see a big and, that means both things have to happen. And whenever you see a capital O-R, that means that one of the 2 has to happen. So 2 events, if they both have to happen, if event A and event 2B have to happen, then you multiply the respective individual probabilities. If one event can happen or the other event can happen, then you add the probabilities. Okay, so let me give you an example of that. If I say, what is the example? What is the probability that I roll 2 dice and they are both have the same value? Then the probability of the first event happening is 1 because any of the dice can have that meet that condition. And then there's you have to multiply it by 1/6, which is the probability that the second dice matches the first. If I'm talking about or, that means one or the other condition. So let's suppose that I say I'm going to roll one dice, and either, what's the probability if I get either a 1 or a 2? Okay, well, the probability of getting a 1 is 1 in 6, and the probability of getting a 2 is 1 in 6. So I'm going to add those together, and I get 1 in 3, which makes sense because, you know, I've got 6 possibilities, and two of the numbers work. So that's 2/6 or 1/3. Okay. So for this problem, let me go back here to this problem and just review it, because now that I've been talking about that. And standard 6-sided dice is rolled twice. What's the probability that the second number rolled is not less than the first number rolled? Express your answer as a common fraction. Okay. So here's what I'm going to do. In this case, the results of the first dice roll do matter, because look, if I roll a 1, how many on my first roll? When I roll the second dice, what is my probability that the second dice is not going to be less than a 1? First of all, can I roll a dice that's less than a 1? No. So if I roll a 1, then the probability of me getting my second roll be greater than or equal to 1 is 100%. So if I roll a 1, there's a 1 in 6 chance I roll a 1, but then there's a 6 in 6 chance that my second dice is equal to or greater than that. Okay. Now, if I roll a 2, my probability of rolling a 2 is a 1 in 6. Okay. But if I roll a 2, how many possible conditions are there on the second dice that can make the number that I roll on my second dice be greater than or equal to 2?
5/6.
5/6, right? 5/6. So the same goes 3, 4, 5, 6. So there's 1 in 6 probability of each of these events happening. 1 in 6 and 1 in 6. For the first dice roll, there's a 1 in 6 probability of each of those things happening, but the probability of my second dice roll meeting the criteria decreases by 1 each time. So with 3, I can get a 3, 4, 5, or 6. So that's 4, 6. And then this one is 3, 6. This one is 2, 6. And this is 1, 6. Okay. So I could multiply all these fractions out, but there's kind of a faster way to do it. One is to say, first, I can factor out a 1 in 6 chance, because the fact of the matter is that each one of these, my first dice roll, there's a 1 in 6 chance. So instead of writing out 1, 6 times 5 or 6 sixes plus, remember, these are each, we're looking for each, either of these conditions. Either of these conditions can be met. So we're going to add these probabilities. So we're going to say 1 in 6 times 6 in 6, 1 in 6 plus 5, 6 plus 1, 6 times 4, 6, etc. Okay, so again, I just want to, just because maybe I haven't been super clear, but I'm actually using both of these rules. One is, what's the probability that one of the events happens? So either A or B. What? Okay, just wait for me and we'll get you the test, or do it on the upstairs computer.
No, it's just not working.
Okay, so what we're doing is we're saying we're adding the probabilities of each of these conditions, but we're multiplying. I mean, we're adding the probabilities of the first roll, but we're multiplying the probabilities of the second roll. In other words, we can have, there's 6 different ways we can get this. One is by rolling a 1, one's by rolling a 2. For those different possibilities, either one of those can work. And I said or, so we're going to add those probabilities. But for each of those first rolls, there's something that has to happen on the second roll. And that means that the first condition has to be met and the second condition has to be met. So we have to multiply those probabilities. That's an and statement. Are you guys kind of seeing what I'm talking about?
Yes.
Good. Okay, perfect. So what we're going to do is we get this 1/6 times 6/6, 1/6 plus times 1/6 times 5/6, etc. So what we're going to do is we're going to just, to make things easy, we're going to factor out this 1/6 here, this 1/6 here, and we get 1/6 times 6/6 plus 5/6 plus 4/6 plus 3/6 plus 2/6 plus 1/6. Well, I can also factor out another 1/6. So I'm going to cross this out and I'm going to factor out another 1/6 and I get 1/36 times 6 plus 5 plus 4 plus 3 plus 2 plus 1. Okay, so that's easy. You can add up these and you can figure out what that is and divide it by 36. But because I want to review a skill, what is the fast way to add up an arithmetic series?
Add the first and last number, and then because that's the average, and then just multiply it.
By the number of pairs. Remember the number of pairs or half the number of the terms. So I'm going to have 6 terms here. 6 and 1 is 7. So since I have 6 terms, I'm going to have 3 pairs. So 7 times 3 equals 21. So my answer is 21/36, I think, except for one problem, and that is if I write 21/36, my answer is going to be wrong. Why?
It's not simplified.
Not simplified. I must simplify. If I don't simplify, then you get the problem wrong, even if you did everything right. So this is that quick thing to do. And I just want to review just another skill, even though I know you guys all know that both of these numbers are divisible by 3. To be like, okay, well, can I simplify this? Well, let's see. 2 plus 1 is 3 and 3 plus 6 is 9, and both of those are divisible by 3. So I know both of these numbers are divisible by 3. I'm going to divide them both by 3, and I'm going to get 7 divided by 12 is the actual correct answer that's going to get you points on this. Does that make sense to both of you guys?
Yeah. Where
Good.
I missed was I averaged everything out at the beginning, so I got 7/6.
Okay.
And I failed to divide that in half. So
Perfect. Well, you're on the right course then. You know what you're doing. Okay, let's go to the next problem. Next problem I recall uses factorials. Have you guys come across factorials?
Yes. But I don't really know why you use factorials. So
Okay. Let's look at the problem and see.
problem.
So factorials come in handy when you're talking about how many combinations there are of something. Okay, so here's what the problem says. And give me a second while I try to find it here. Okay, this is what the problem says. How many 4-letter words can be used using all the letters in the word beep, B-E-E-P, if the 2 E's are indistinguishable? 2 such words to include are beep and e-beep, or e-bep, E-B-E-P. Okay, so let's go back to my whiteboard here. So they give us 4 letters, B-E-E-P. And they say, how many combinations are there that you can arrange these 4 letters? Okay, now this is super important. They say these 2 E's are indistinguishable. And the reason why that's important to know is that if the question had been, how many ways can you arrange this, B-E-S-P, then there would be 4 different letters that we could choose from, and all 4 of them would be indistinguishable from each other. And so they have to specify that these 2 E's, you can't tell them apart. Okay, that'll come important in our calculation. Okay, so here's our 4 letters, and we're trying to make 4-letter words. So let me ask you this. Here's our 4 slots, 2, 3, 4. how many of these different letters could I put here? What are my choices? What are the choices that I can write right here?
B, E, and P.
B, E, and P. Okay, good. So you're saying that there's going to be 3 choices here. Now, you're already sort of jumping the gun by recognizing that the 2 E's are indistinguishable. So I'm going to ask you a slightly different question. Let's suppose that it's B, E, S, and P. Let's do that problem first, okay? How many letters can I put here at the beginning? 4.
Four.
B, E, S, or P. How many letters can I put here in this slot?
Also 4.
So here's the thing. If my first letter was B, I can't have my second letter be B because I've already used B. And they're not saying how many different ways can you throw the letters in there. How many different ways can you use these letters? So you have to be kind of careful here. So let me read the problem again. They're saying how many 4-letter words can be made using all the letters in B, E, E, P. So if they had not said all, you could do this. You could say B, 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 P, B, 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 S. You could go on like that. And in that case, it would be 4 by 4 by 4 by 4, multiply 4 to the 4th power. And that's how we calculate. There'd be a huge number. But they said you have to use all the letters. So if that's the case, then it's true that our first letter has 4 choices. Remember, we're doing this one over here. It can be B, E, S, or P, which means there's 4 choices for our first letter. But there's only 3 choices left for our second letter because we've already used one of the letters and we have to use all of them twice. I mean, we'll have to use all of them once. So for our second letter, there's only 3 options left. And for our third letter, there's only how many options are left?
2.
2. Sorry. And for our last letter, there's only 1 option left. Okay, so here's where, Jackson said, what's the point of a factorial? Here's the point of a factorial, is that if I want to know the total number of combinations, I have 4 options for the first slot, 3 for the second slot, 2 for the third slot, and 1 for the last slot. I have to multiply 4 times 3 times 2 times 1. And that equals 4 factorial. So for those of you who are going to be watching this later, factorial means multiply 4 times 3 times 2 times 1. There's a special symbol in that for math because it comes up so often. And it especially comes up so often in math counts. They love to throw in these kind of combination problems. And combinations means factorial. So I just saw I have a message here. Let me see what that is. Did I say something other than exclamation mark? So anyways, so this is 4 factorial. So what's 4 times 3 times 2? Well, 4 times 3 is 12 times 2 is 24 times 1 is 24. Okay, so the answer is 24. Okay, that's if I'm doing this problem where every letter is distinct. But I'm not doing this problem. I'm doing this one. Okay. So I have 2 letters that are indistinguishable. Let's call them E1 and E2. How many different ways can I arrange E1 and E2? I can either have E1 be the first slot, or I can have E2 be the first, and E2 be the second slot, or I can have E2 be the first slot, and I can have E1 be the second slot. So there's two different ways that I can arrange my E's. So this number 24, I have to divide that by 2 because there's 2 different ways that I can arrange the E's. And since they're indistinguishable, only half of them are going to count. So for example, if I have B, E1, E2, P, and I have B, E2, E1, P, those, when I'm doing my factorial calculation, those look like 2 different possibilities, but they're indistinguishable from each other. So instead of 2, I have to divide by 2, and I get 2 divided by 2 equals 1. And these are counting for the sake of the way they're asking the problem as one combination. Let me just take a little side tangent. Suppose that I had had A, B, C, 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 and the question was, the C's are indistinguishable. How many different ways can I arrange these letters? And again, the C's are indistinguishable. So here I would say there's 5 choices for the first, second, 4 choices for the second, 3 choices for the third, 2 choices for the fourth, and 1 choice for the fifth. So that is 120, right? 5 factorial, that's 20 times 6, yeah. 120 equals 5 factorial. But my C's are indistinguishable. How many different ways can I arrange the C's? Well, I have C1, C2, and C3. How many different, let's suppose that I have, so I'm going to say I have a first, a second, and a third C. How many different C's can I have for the first choice? I have C1, C2, and C3. 3. How many different C's do I have for the second choice? I have 2. And how many C's are left for the third choice? 1. So for this equals the arrangement of the C's, I have 3 factorial equals 6. So because these C's are indistinguishable, I have to take my 5 factorial and I have to divide it by 3 factorial. Or I have to take 120 and divide it by 6. And my answer is 20. Okay, so they will always say, if it's just a combination problem, that combination means they'll say, you know, it'll be clear to you that the order doesn't matter, or that that the letters are indistinguishable, or that they're non-indistinguishable. So if they come up with different letters, those are all distinguishable. But if there's letters in common, they will always say these letters are not distinguishable. Okay, does that kind of make sense, you guys? Good. Okay. So we have I think 3 more problems, and I think the other ones are pretty quick. Let's take a look. Well, we have 2 more problems. Okay. So this one came straight out of what we did last week. Okay, so the question is, Tia decided to average her cost for utilities last year to project her expense for the future. Last year, she spent an average of $216 per month on utilities, but she anticipates a 5% increase in the annual cost of utilities. Based on this information, how should she expect to pay for utilities each month this year? How much should she expect to pay for utilities each month this year? Well, for this one, it's just like what we did last week when we're calculating tips. She said $216 per month, and she expects to pay 5% more. So if we want to multiply 216 by what she's going to be paying, what additional amount she's going to be paying, what do we multiply 216 by? Just like calculating a tip. Remember, if I have $30 for my dinner and I have a 15% tip, I'm going to multiply that by 1.15. Okay, so what am I going to multiply 216 by if she says she's going to use 5% more next year?
1.05.
Okay, so this is called I think this is called the target round. And in this particular section, you were able to use a calculator. So we do 216 equals 1.05, and whatever that is how much she had. So you have a calculator. I'm not going to go through that calculation, but that's how you set up that problem. Okay, and then the final problem that everyone who took the test missed was this one. A block of cheese measures 5 by 2 by 3 inches and is coated with a very thin layer of wax. Okay, they specify very thin layer of wax. I'm going to come back to why they say that. The cheese is sliced into 240 cubes with 1/2 inch edges. How many cubes will not have any wax on them? Okay. So first of all, I think it's handy to draw a picture of what we're talking about. Do you guys know how to draw three-dimensional pictures? So if you want to draw a three-dimensional cube, you first make a rectangle, then you make stuff coming out, and all these edges have to be parallel. And this is actually kind of a handy skill. Then you connect these edges. Those show the outside of the cube, but you also want to show the hidden edges. So I'm going to go like this. And then I'm going to put in the dimensions because that's important. I'm going to go 2, 3, and 5. Oh, I have one more edge that's hidden that I got to show. Okay, and you show those with a dotted line. So that's rough, but this is a really good skill to learn. And I'm kind of saying this for the guys who aren't in geometry yet, who are going to watch this later. You guys, Jackson and Ethan, you guys probably know how to do this, right? Perfect.
Yeah.
Okay. So I have to confess that when I first read this problem, I was a little confused because I was picturing this block of cheese. Oops. I was picturing a cheese round, which is a cylinder. And then I was like, well, why are they giving me 3 dimensions? I really only need a radius and a height. And then I realized they're talking about a rectangular block. If I had written that question, I probably would have said a rectangular block of cheese, just to prevent idiots from me from going down the wrong path at first. But then the question is, so we coat this with a very thin layer of wax. And the reason why they say very thin layer is that the very is a message to you. And the message is, it's so thin, don't add that into your calculations, okay? So the fact that they didn't give you a thickness for the cheese means that you can throw it out, okay? Because if they had wanted you to include the thickness of the wax, the thickness of the wax, they would have said, okay, the wax is 1/8 of an inch thick. But the fact that they said very thin, they just want you to realize that you don't need to include the thickness of the wax in your calculation. Okay. So they say we're cutting the block into 1/2 inch squares, 1/2 inch cubes. And we want to know, now do they want to know how many cubes don't have wax or how many do have wax? Let's go read the problem again and make sure we get this right. So it's a block of cheese is measured 5 by 2 by 3 inches. It's coated with a very thin layer of wax. The cheese is sliced in 240 cubes with 1/2 inch edges. How many cubes will not have any wax on them? So I'm willing to bet that some of the people who solved this problem and got the wrong answer got it wrong simply because they didn't read the question. And instead of calculating how many cubes don't have wax, they calculated how many cubes do have wax. Okay, so let's go back. So the fastest way to do this is to say, look, let's divide up this block of cheese not into inches, let's measure it in 1/2 inches, okay? So if I'm measuring, because each of the cubes is going to be a 1/2 inch, right? So if I have something that's 2 inches high, a block of cheese that's 2 inches high, but I want to measure it in 1/2 inch cubes, how many cubes high will my block of cheese be?
4.
4. And same thing for these other dimensions. Instead of 3 and 5, I'm going to do it in 1/2 inch blocks and get 6 and 10. Now, I just want to for you guys who are in geometry, I'm going to just bring something out, a point out here. No, I'm not actually. Sorry, I was thinking that the dimensions here were 3, 4, and 5. And anytime you see anything with dimensions 3, 4, and 5, the very first thing that has to go through your mind is that could, having a perfect right triangle with dimensions 3, 4, 5 might be part of the solution. Now, as it turned out, it's not part of the solution in this case. And I messed that up for some reason. I mean, it was 2, 3, and 5, not 3, 4, and 5. But these perfect right triangles with integer sides come up all the time. So anytime you see them say 3, 4, 5 as a dimension, you immediately say, is a right triangle, perfect right triangle involved in this? Okay, but in any case, I messed that up. So sorry about that. Oops, eraser. Okay. So there's 4. So now our cube, instead of 2, 4, 2, 3, and 5, are now 4, 6, and 10 half-inch cubes. Okay, so what is the total number of cubes that we're going to make here? What's the total number of half-inch cubes? It's going to be 4 times 6 times 10, right? And that equals 24 times 10 is 240. Okay. But we need to figure out how many of them don't have wax on it. So let's just shell out the outside layer that has the wax. Okay. So first of all, in this dimension, of these 4 half-inch blocks, I've got 1, 2, 3, 4. How many of them do not have wax on them? How many of these do not? I'm sorry, just looking at this dimension, we're going to throw out the outside edges. So we're going to throw out this edge. I'll draw this all the way across. And we're going to throw out this edge. So I'm left with 2 cubes in this height dimension that don't have wax on the top and bottom. Okay. Do you understand what I'm saying here? You look confused, Jackson.
I thought there was wax all around the cheese.
There is. Okay, I'm trying to think how I can show this.
He's just trying to make the calculation easier for the bigger ones because the corner cubes are also have wax on the top. It's not just the side.
Right. So one thing I could do is I could calculate how many. I'm trying to see if I can explain what I'm doing here. So one thing I could do is I could calculate how many slices, how many cubes have wax on them. And originally what I did was I said, I calculated the surface area of this. And then I said, well, each one of these items, each one of these surface areas is going to have 1/4 of an inch of wax on it. But what I neglected is that the corner cubes, so here's a corner cube, it has wax on 3 sides. It has wax here, here, and here. And the edge ones, the ones that are like right here, if I took a cube right here, that has wax on 2 sides. So that doesn't work either. So what I'm trying to do is I'm trying to shell out the center of this wax by peeling the outside out. And let's see if I can figure out a way to explain what I'm trying to get at here.
I think I get it. You have to, you're trying to eliminate the top and bottom rows because they have wax, and then you're going to do that same thing for the 10 side.
Yes. Yes, thank you. Thank you. That's a great way of putting it. Okay.
That's what I...
Okay, perfect. Thank you. That was a great way of putting it. So basically what I'm going to do is I'm going to core out a section here that's 1 cube less in each dimension. And it's going to go like here. And I'm going to core out that section. So what I'm going to say is out of this top, out of this vertical dimension, I'm going to get rid of everything here, and I'm going to get rid of everything here. Instead of 4 cubes high, I'm only going to have 2 cubes in this central core. And then in this dimension, in the width dimension, I have 6 cubes, but I'm going to get rid of everything on 1 cube on 1 width on the left and 1 width on the right. So instead of 6, I'm going to have 4. So my central little core that doesn't have wax on it is going to be 2 by 4. And then how long is that central cored out area? Well, the original area is 10, but I'm going to get rid of 1 section of cubes here at the back, and I'm going to get rid of 1 section of cubes here at the front. And what I'm left with is how many? 8, right? So 2 times 4 times 8 is 8 times 8 is 64. Now remember, I'm going to check one more time because this is going to be a place where I'm going to screw up. Are they asking for how many do have wax or how many don't have wax? The answer is we're looking for how many don't have wax. And that's what I just calculated. So I just want to double check that. And the answer is 64. Okay, so that's it for today. I think, Ethan, you did great. Those were the only problems you missed, I think. Not 100% positive of that. I'll send you your results so you can see them for reals. But I think those were the only ones you missed. And like I said, everyone who took the test actually missed those same 5 problems.
Yeah,
So
I got a couple of stupid mistakes on some of them.
exactly. And, that's par for the course. And what's the cure for stupid mistakes? Practice. So, go back into Mathcounts and then go to Mathcounts Trainer and do problems, and you're going to do great. So, Ethan, you can hang up if you like, and I'm going to end the video here, and I'm just going to talk to Jackson, and we're going to see if we can figure out how to get him enrolled so he can take these tests. So, anyways, thanks, Ethan, and thanks everyone who's watching this on video. I'm going to end this now. Okay.